My name is Joshua Hunt.
I'm Dustin Littell.
And I'm Robert Maxwell.
Today we're going to talk to you guys about the concrete conundrum and how CLT panels could potentially be replacing concrete, which would have a big impact on carbon emissions globally.
So what exactly is the concrete conundrum? Well, the concrete conundrum is twofold. First of all, concrete is the single most widely used material in the world. The demand for concrete globally is second only to water, which is impressive. The Columbia University Earth Institute actually reported that there's enough concrete produced globally every year that each individual around the world could have more than 3 metric tons per person of concrete, which is impressive to say the least. The second part of the concrete conundrum, though, is that as much demand for it as there is, it also produces a significant amount of carbon dioxide. In May of 2012, it accounted for 5% of global carbon dioxide emissions, and in December of 2018, it accounted for 8% of the world's carbon dioxide emissions, which is a 3% growth over 6 years. And if that continues to grow, that could be a very big problem. It's already a large enough problem as it is, but because demand for concrete and construction continuing to grow, it can become a much bigger problem. So what is it about concrete that produces so much carbon dioxide? The biggest factor in carbon emissions from creating concrete is actually the cement. Most of the other materials can be found naturally, but cement has to be produced. Normally Portland cement is the specific type that is used for concrete. And because of the heat and the energy intensive process of producing this cement, it produces a lot of CO2. Specifically clinker, in order to produce that, it's very energy intensive. When that happens, it produces a lot of concrete emissions. So the best way to reduce concrete emissions is to not use the cement or to try to minimize it.
So the current solutions for this involve changing the way we use our cement. So the first of these is fly ash. Fly ash, when added to cement, will make the concrete far stronger and far more efficient, thus reducing the amount we need to use, which inherently helps with emissions because we're just using less. After this, we have recycled aggregates. So this is taking previous concrete and reusing some of it as aggregates to new concrete. This is your basic reuse recycle, and this allows concrete, once it has gone through its life cycle, to go back into new concrete and thus have a longer life, be more efficient, and reduce carbon footprint. And finally, the example we have here is tires, but there's lots of research going on into using other industrial materials as aggregate for concrete, some more successfully than others, and all of these are great examples of recycling and reducing the amount of natural resources needed for our concrete. So this is a house that I like to call the lone survivor. This is a house in Florida, and after a hurricane, it was the last thing left standing. Everything near it had been torn down. And the reason this building was left standing is because it was the only concrete structure in its neighborhood. And this is kind of how we see the conundrum with concrete and with a lot of other large environmental issues. It's detrimental for society and for the world for this house to be built with concrete because it's wasteful, it takes up natural resources, it has carbon emissions, but for this individual it was a very good thing. And really the only way we can solve these problems where something is good for the individual and bad for the collective is either through litigation and legislation or through a process by which a new technology leads to the obsolescence of the old technology. And that is what we will be talking about, something that has the potential to lead to the obsolescence of concrete.
So these were examples of the historic approaches to dealing with CO2 emissions from concrete, but there are some new up-and-coming technologies that could potentially replace concrete entirely. One of these is cross-laminated timber, which could be used to replace concrete shear walls and structures.
This is a recently completed test in Alabama's large-scale structures lab of a hybrid structure using CLT columns in place of concrete shear walls and combining that with a regular light frame structure. So thankfully, because this is recently completed, we've started tear down, and you can see the skeleton of what's going on here. On both sides you can see CLT columns that are supporting the structure, and the center a normal light frame structure with 2x4s and plywood. This is a sample of what a cross-section of one of the panels would look like. You can see that there are 2x4s laid across in layers in one direction. And then if you look at the cross-section, you can see each layer runs perpendicular from the previous layer. This allows for the tubular geometry of the wood to face in different directions, so you can get high compressive strength in both directions. concrete shear walls?
The project we're working on is try to combine COT with traditional live frame wood structures.
Right.
So compared with that, COT is the better material
The better material.
to combine with live frame wood structures, because wood to wood and wood is easier than concrete and wood.
Right.
Performing seismic load is also very good too,
Okay.
because it can dissipate energy and it's very ductile material compared to concrete. Using COT have several advantages compared to concrete. The first thing is it's lighter,
Right.
so it has less seismic load on it, because when you have more weight, it means that when the earth shakes, you have more inertial force.
Right.
So with that, with COT, you have less inertial force with the same acceleration. The second one is because it's light, you can save the money from building the foundation. So because building is lighter, you don't need much foundation.
Oh, okay.
So you save money from that too.
Right.
Another thing is because it's wood, it needs less labor.
Right.
Construction faster, you save money from that too.
Right.
So it's easy to construct with wood. The worker does not need much training for construction. So with a small group of workers, you can start with COTs from construction. So it's much easier than that. And also, if you see the building construction with COTs recently, you see that there are not much machine on the site
Right.
because of that. It's light and easy to handle with hand.
Exactly.
So it's very easy and fast.
Safer workplaces.
Yeah, safe workplace. And
I thought,
easy.
I thought it was interesting. We were talking earlier. You mentioned as well, because wood is a natural resource. It's both sustainable and also has a negative carbon footprint. Right.
Yeah, that's for sure, because it has negative carbon emission compared to other materials. So
Especially concrete.
yeah, that's why federal funding resources, they really support for this kind of material, research in this area.
So to summarize our findings, concrete has a very significant impact on carbon emissions worldwide, which has a big impact on global warming. But in contrast to traditional methods of dealing with that, which normally involve either changing the mixture of concrete or just not using concrete at all, CLT panels, cross-laminated timber, could potentially replace concrete altogether. From our interview, we discovered that CLT panels function just as well practically as far as strength considerations go for concrete, and is actually something that produces a much safer workplace, has a negative carbon impact, and could be more useful and functional for high-rise buildings as well. Thank you.